Well, folks, welcome to another Math 103 class. We are going to begin the class today by going over the sheet called Group Work number 7, which I assigned you to do last night. So would you please make sure you have that out, and we will go over it right now. All right. And then we're going to get back into the prime factorization stuff I started yesterday. And we're going to talk a lot about that today. And then we're going to do eventually a massive review for the big test that I'm going to give you. But we'll talk about that as time goes along. Okay, so, all right. So I'm going to now share the screen with the homework. So let me do that right now. And that should be here. So let me share it. And let me get myself up in the corner out of the way here. And away we go. All right. Well, the first question we answered, and the second question we answered, and the third one on Group Work 7 yesterday, but let's review them again. What does that symbol represent? That symbol represents a term we call the golden ratio. The golden ratio. And remember, the golden ratio was basically derived from taking Fibonacci numbers that were next to each other, taking the larger of the two and dividing it by the smaller. And we found if you went out to larger Fibonacci numbers, okay, in the series, you approach this value. And the exact value was determined by using that 1 plus 1 over 1 plus 1 over 1 plus 1 over 1 stuff that Dr. Ed went over with you and I went over with you briefly yesterday. Now remember, I will not test you on that material, okay? I will expect you to know this, but I will not test you on that derivation, okay? So we ended up using the quadratic formula in the end, and we found that the exact value of the golden ratio is that phi is equal to 1 plus the square root of 5 all over 2. Now, if you take a calculator and you work that out, okay, into a decimal equivalent, you first have to do the square root of 5, okay? Then you add 1, hit enter to hit equals, and then you divide it by 2. And what do you end up with? The correct value of the golden ratio to 6 decimal places for phi is 1.618034. All right, and I'm going to expect you to know the following information for the test. This and this. The actual uses of these things we are going to get into more as we continue the course, okay? But at least for right now, you have learned about the golden ratio, and you're going to find out it is everywhere, okay? And we'll discuss that as we get further, as I said, into the course. All right, so let's continue. I don't believe I have anything else on this sheet. Let's go to the next sheet. Picking a Fibonacci number f sub n greater than 7, verify the following formula. Following formulas are actually valid. They will actually work. All right, well, here's what I did. You didn't have this on the sheet I gave you, but you had other Fibonacci tables around, so you could get to the Fibonacci numbers by going to one of your other sheets that you've printed or that you have in your possession. So I put the Fibonacci's and the Lucas up here on the screen so that we can easily see where the numbers come from I pick. All right, I am going to use, let's use n equal to 9, okay? So if we use n is equal to 9, let's see what this first formula would put out for Fibonacci numbers we're going to check. All right. F9, if I put 9 in for n in the first piece here, I get what? F sub 8. If I put 9 in the second piece of the expression, I get F sub 10. If I go over here and I put the 9 in for n, okay, I would get f sub 11. And if I go to f sub n minus 2, it would be f sub 7. Now, is it true that if I put the actual values of the Fibonacci numbers in here, will this statement be true? Will the two sides be equal to each other? Well, f8 is 21. F10 is 55, right? Looking at the table. F11 is 89, and F7 is 13. So if I add 21 and 55 together, you can see I get 76. Is that equal to what's on the other side? 89 minus 13 is also what? Wait a minute, I subtracted wrong. It's 76, right? 76, sorry, I said 76, I think, and wrote 75. 89 minus 13, what is that? That is also 76. It checks out. So for this sentence to work, it appears that no matter what Fibonacci numbers I place in that sentence, the left side will come out equal to the right side. All right. Let's go to the second one. All right, I'm going to use, let's try n equals 10 this time. All right, if n equals 10, then I fill in the subscripts. F sub 10, is it equal to 2 times f sub what? Well, n minus 2, the subscript, would be 8. Okay, and then I add to that f sub n minus 3, well, that would be f sub 7, right? So what is f10? Well, it's 55. Is that equal to 2 times Fibonacci number 8, which is 21, increased by Fibonacci number 7, which is 13? Well, if I double 21, I get 42, and if I add 42 and 13, I do indeed get 55. So this checks out, okay? So the left side will indeed equal the right side. I will give you a couple of problems like this on the test that's coming up that you're going to get later today, which I'll talk about, or tomorrow, whatever. So what I'm going to do is make you realize that you are going to have these types of questions where you have to deal with the subscripts and get answers to make sure things work out, okay? All right, let's go on. Write the natural number 1006 as the sum of non-consecutive Fibonacci numbers, okay? Keep an eye on me now to make sure I don't make a mistake. All right, we're doing Fibonacci numbers, okay? So what is the closest Fibonacci number to 1006 that is smaller than it? Well, you can see from my table up there, it's 987. So now what I have to do is take 1006 and subtract 987. And when I do, I get what? 19. Okay, now, is 19 a Fibonacci number? No, it's not, right? So I have to continue. So I rewrite my 987 plus, what's my closest Fibonacci number to 19 that is smaller? Okay, well, it looks like it's 13, right? And how much am I missing 19 by? I'm missing by 6. Well, I have to work on 6 now because it is not a Fibonacci number. What's the closest fib to 6 that's smaller? It's 5. And what do I need? 1 to get 6. 1 is a Fibonacci number, so guess what? I'm finished. So I have written this as the sum of non-consecutive Fibonacci numbers. Obviously, a question like this will be on your upcoming test. Let's go on. Number 6, how many folds of a large single sheet of paper must be made for the folded layers to reach a height of 15 feet? Well, remember, I'm going to have to get 15 feet converted over to what? To sheets of paper. All right, so let's do that. 15 feet, I use dimensional analysis over 1. There are 12 inches. Remember, I put the 12 on top because feet has to go on the bottom, so it will cancel. So now my answer would be in inches if I multiplied these two together. And now what do I use for a conversion factor? A conversion factor for inches into sheets of paper is, for every 1 inch, there's 250 sheets. Now, where does the 250 go, and where does the 1 go? Well, it's 1 inch, right? Inches has to cancel, and it's 250 sheets, right? Okay, so this answer will be in sheets, so I'm going to do that over here. 15 times 12 times 250, and that gives me 45,000 sheets of thickness. Now, by folding a piece of paper in half, how many times will I have to fold it to arrive at least 45,000 sheets of thickness, or more, just a little more? So, in other words, I'm asking myself, what power of 2 do I need to reach 45,000 or just beat it? It's T&E time, right? T&E, trial and error time. So I take my calculator, if I can find wherever I stuck it here. Oh, here it is behind this sheet thing over here. All right, and I can do powers on this particular calculator. So on your calculator, you should start taking powers of 2. Let's try 2 caret 10. I got 1,024, way too low. Let's try 2 caret, maybe 15. 2 caret 15. Remember, the caret key is the key that does the powers. Okay, I obtain 32,768. I'm pretty close, right? But I'm not large enough. 32,768 doesn't make it, right? But you know I'm going to be doubling this, right? So when I go to 2 to the 16th power, so I'm going to clear this. I'm going to go 2 caret 16. And when I do that, I get 65,536. So that definitely beats it, right? So 65,536 would beat 45,000, 32,768, which was 2 to the 15th, is not large enough, okay? So how many folds would I need to beat this height, to reach it or beat it? I need 16 folds. Now remember, when you take the test, you've got to remember, you've got to tell me the number of folds. The correct answer to this problem is not 2 to the 16th. The correct answer to this problem, I asked you for how many folds it is, so my correct answer would be 16 folds. Okay? All right, let's go on. Number 7, convert 87 years into seconds. Again, example of dimensional analysis. All right, so I'm going to start with 87 years. Remember, we don't go to months, we don't go to weeks, we go right to days, because it's a more accurate estimate of what is in a year. Okay, so 365 days for every 1 year. Years would cancel. I'm now at days, but I want to be in seconds. So I have to go to what next? Have to go to hours. Where do hours go? Well, days has to go on the bottom, so it'll cancel. So for every 1 day, there's 24 hours. Remember, there's not 24 days in an hour, all right? So you know where to put the 24, all right? Well, I guess my next step would be minutes, right? So for every 1 hour, I will have 60 minutes. Okay, I'm almost there. I will go to 60 seconds for every 1 minute. And now if I do this computation, since all the numbers are on the top, it's very simple. I simply do 87 times 365 times 24 times 60 times 60. And when I do, the answer I obtain is huge, really huge. I almost think it's too big, so I'm going to start over in case I made a mistake. 87 times 365 times 24 times 60 times 60 equals, no, it wasn't a mistake. It is, it looks like 2,743,632,000 seconds. You've lived a lot of seconds, my friend, if you can live until the age of 87. That is a lot of seconds. Okay? All right. Very good. So we have finished our first part of what I want to do today, and that was going over the homework. Now, hopefully you have remembered to send me the answers to both video quizzes 6 and video quiz 7. You don't have to print the quizzes to send them to me. All you have to do is text my phone number, say your name, put VQ6, and put your answers down, 1, 2, 3, 4, 5, and next to it, your choices. Same thing for video quiz 7. And when you do video quiz for me 8, very shortly or later today, or in the next class, whenever I give it to you, you can do exactly the same thing. Okay? All right. So let's go on.